before we go into that, I figured I would give a quick talk on LangChain, what it is, how it relates to MindsDB, in particular interacting with data that you might have in an enterprise setting, which MindsDB can help you connect to. So LangChain is an open source developer framework for building applications with language models. Specifically, we're focused on a lot of the glue that connects language models to other sources of data and computation. So part of the thesis of LangChain is that language models are awesome and powerful by themselves, but they can be a lot more powerful, a lot more personalized when they're connected to your particular data or your particular APIs and help build more interesting applications that way. We have Python and TypeScript packages, really focused on composition and modularity. So part of our belief also is that it's extremely early in this ecosystem. It's extremely early in building these applications. And so we want to focus on building a lot of the core components that we think will be important. We don't exactly know all the ways that they'll be put together to build applications, but we want to focus on enabling all of those as best we can. And so talking a little bit more about that, we have a bunch of different components and then a bunch of ways of like stacking these together to have like more use case specific chains. So talking about the components, there are two separate categories. Some are ones that we've implemented ourselves within LangChain, and then others are ones that we just have integrations for. You know, part of the exciting part about building in this area is there's so much stuff going on. There are so many different model providers, vector store providers, retrieval mechanisms that we want to be a way to easily connect with all of those. So those are the ones on the right. Those are models, vector stores, retrievers. We don't actually have any language models of our own. We just provide a standardized interface for interacting with OpenAI, Anthropic, Cohere, the open source models, Mosaic, everything like that. So part of the same thing for vector stores. We integrate with Pinecone and Weavy. We don't have our own, and then same thing with more generic retrievers. And the idea there is basically, I think there's a lot of value in being able to easily switch between like OpenAI or Anthropic or a Hugging Face model. And so having a standardized interface allows people to easily do that. The other ones on the left are things that we've built into the core library. And so these are things that are new and we think are kind of like fundamental building blocks for building with language models. And I'm going to skim over these really quickly, but there's documentation on our site about all of those. Prompts are basically ways for interacting with language models. These are a new thing, right? These didn't really exist, up until a year or a few years ago. And so we've got a lot of functionalities for creating and working with and composing different types of prompts. Output parsers is basically taking the output of a language model, which is a string, and turning it into some structured information, which is good when you need to do downstream tasks with it. Example selectors are ways of inserting few-shot examples. It's a technique to construct more comprehensive prompts. Document loaders are really important, so they're a way of loading unstructured data. So previously, there was some use cases for like web pages and PDFs, but now there's a lot more because you can just kind of feed them into a language model and ask questions about it. So there's a lot of integrations there. Text splitters are also very important here. A lot of language models have context length limits, and so you need to split up text before passing to it, and so we've got some integrations there. And then memory is a concept when you've got a chatbot and you're interacting with it, it's stateful, right? It remembers what you said before, and so that's a very, very simple form of like short-term memory, and you can start to imagine more complex forms where it remembers things over time, and so we've added some functionality there. The things on the right are basically a bunch of applications that you can build with LangChain, and again, these are just kind of like the starting point. We really think there are so there are a lot of much more applications than these that you can build with LangChain. So these are the ones that we have kind of like good support for just getting started with, like 1, 2, 3 lines off the shelf. The goal between these two things is to make it really easy to get started with an end-to-end application, basically, but then also really easy to customize it for your own particular application by taking the modular parts. So because this is a MindsDB conference, I figured I would talk a little bit about how to interact with tabular data before handing it off to Patricio. And so when thinking about interacting with tabular data, there's a few different ways that you can do this. And there's not one way that's right or wrong. It depends on the type of data. So the high-level approaches, as I kind of see them breaking out, are one, you can start to index the data into a vector store. And this is really good when you have a lot of text data that is in a database. So if you have 1 or 2 fields that are very text-heavy, long text strings, you're probably going to want to do things like interact with that, do question answering over it. And so putting that in a vector store and enabling things like semantic search will be a lot more powerful. On the other hand, you can often have tabular data that's just numbers. And so it's actually much more powerful to interact with that data directly, whether it's in a SQL database, in a pandas data frame, in a CSV. And so you can actually just interact with that data directly rather than transform where it lives. And then the third approach is combining these and getting the best of both worlds. So diving into this a little bit, this is an overview of what it generally means to load data into a vector store. And so this powers a lot of the retrieval augmented generation, if people are familiar with that term, which is basically the idea that when you want to ask a question of PDF or of documents that something like ChatGPT hasn't seen, the general approach for doing that is to retrieve those documents and then pass those into the prompt and basically say, answer this question only with the data that's present. And so the first thing that you need to do there is some pre-processing step or an indexing step, where basically you load the documents into an index where you can then query them and get only the most relevant documents, because this is useful when you've got so many documents you can't just pass them all into the language model directly. So you want to find the most relevant documents, so you want to put them in an index that easily enables that. And the general workflow here is up there. You load it as documents, you chunk them into small chunks, you create an embedding, which is a numerical vector for each document, which allows really quick similarity lookup, and then you put those in a vector store, which is a database designed to make that lookup really, really fast. Then once it's in there, you can do the query. So you fetch relevant documents, you pass the documents and specified metadata into a prompt, and then there's a few different methods that LangChain supports for actually combining this with the language model, and these depend on the number of documents that you have, the length of them, and so on. And I'm not going to go into too much detail about them here. Concretely, what this looks like in LangChain, and I have like URLs to all the code snippets as well, and I'll post these slides somewhere afterwards so they're available. For tabular data, there's a CSV loader, so you can load the data into documents. If you look at the documents here, you can see that there's the page content where basically what happens is team is like a header column, nationals is the value, payrolls is another header column, and this is now on another line, and then you've got the number, which is another value, and then you've got a bunch of metadata, so where it came from in the row, and this can be useful for more complex downstream things. You can then index it. So this is creating the vector store. It's 4 lines of code plus a few import statements, and the different components here, the text splitter, the embedding model, and the vector store are all swappable. And then this is what it looks like to query it. And so you pass in a language model. This is the OpenAI language model here. You pass you pass in a way for combining these documents, and you pass in the retriever, and then you can start asking it questions. The next method for interacting with tabular data is just interacting with the data directly. And so this is good when there's a lot of numerical data in it. It doesn't really make a lot of sense to do semantic search on numerical data. So what you can do is you can just interact with it directly. And the 2 ways that we support that in LangChain are interacting with it if it's in a SQL database, or interacting with it as if it's in a pandas data frame. And if you've got some data in a CSV, you can just load it into either one of those and do that. And so what that concretely means is you use the language model to write a SQL query or write a Python command that helps answer the question. And then you run that command or query, get back a result, and then use that to answer the question. And so there's a bunch of nuance here, the main one being how do you construct the prompt with context. So you need to tell it what tables are present, what columns are in those tables, what the types of those columns are, sometimes for the categorical columns, like what the values are there. And so there's a lot of complexity that actually goes into letting the language model construct a SQL query correctly. Once you've constructed that prompt, you can pass it to a language model. It will return a query. You run it. You get back a result, and that summarizes. And then you summarize it with the language model again. And so this is what it generally looks like for a simple SQL chain. And so in this chain, you get the incoming question. That question is then turned into select count star from album, where artist ID equals 3. It returns a result, and then it passes it to a language model, which summarizes it. And this is using a chain. And in LangChain, chains are generally referred to like predetermined sequences of steps that are run in a particular order. This contrasts with agents. So agents are more complex. where basically if a chain is a predetermined sequence of steps, an agent now decides what steps to do and in what order. So concretely, it will decide to take one step, run it, get a result back, then decide to take another step, run it, get a result back. And so this is more complicated, so they don't always work as well. But the pros, and it's also more costly, so it takes longer. The pros are that it can handle edge cases a lot better. So there's a lot of conditions where just that simple predetermined sequence of the steps, even if you start to add in like if statements or things like that, can start to get a little bit unwieldy. It can also handle errors. So if a step in that chain like errors, you're kind of out of luck. But with an agent, you can actually pass the error back and ask it to kind of fix its mistake. And then it can do multi-hop reasoning more easily. So if it needs to look up one thing and then look up another thing based on the result of the first thing, and then maybe even look up a third thing based on that, agents can do that. And I think Patricio's demo will actually show off an agent later on. And so we have SQL and Pandas agents as well in LangChain. And you can see here, there's a lot more things on the screen, which we won't dive into it, but basically you should just treat that as there's a lot more things going on, which again is both good and bad. So here, and this is working on like a really big database. It actually looks up the relevant tables and the relevant schema because we don't pass those in because there's not enough context. There's not enough space in the context window too. And then on the right, you can see some more complex things where it's doing a few different queries. And then the last point that I'll say is that you can actually just combine these as well. So there's powers to both of them. There's powers to putting in a vector store and doing similarity search. You can capture a lot of semantic meaning there. But again, if there's numbers, that might not be the best approach. And again, when combining them, there's a few different ways you can do this. There's a chain, which is a more simpler thing, which is basically picking one and then going to that one. And then there's an agent, which is picking one, going to one, getting back a response, picking another one, going to that, getting back another response, and then exiting whenever it feels like it has the correct answer. And so those are both supported in LangChain as well and you can see here it's routing. So can you see the mouse? Yeah, so here you can see that it's routing to a particular vector store, which we've named like State of the Union or Paul Graham essay or personal. And then in the agent, you can see that the action corresponds to the place where it needs to go. So similar ideas. This, again, is powerful because it's handling multi-hop. It's looking up things from multiple different data sources in one go. This is more simple, so it's more controllable. It's easy to understand what's going on. That is all I've got. That's an overview of LangChain. Now Patricio is going to show why it's actually interesting for today and how you can use it with MindsDB.
Right. Hello, everyone. Connect this. Working. Yeah, easy. Right. So thank you all for being here. Pretty exciting. So I'll be focusing on how to build a domain expert agent, essentially marrying MindsDB with LangChain. And we'll be taking a closer look at how the integration actually works. So how we did it, what are some next steps in terms of covering all the vast ground of work that LangChain has available as tools for devs, right? So I think we can start by looking at the ML engine abstraction in MindsDB. This is one of the main abstractions we've developed in the recent past. It's enabled us to essentially integrate over, I think, by this point, 10 ML frameworks. It includes our own AutoML engine, Lightwood, but there's a lot of other integrations going on, Nixla for time series, direct access to the OpenAI API, and then there's LangChain. So we essentially have exposed it as an additional ML engine with a twist, which is the interesting bit that we'll discuss here. So you can think of an ML engine just basically as a template, a class with a series of high-level methods, of which probably the most important ones are create and predict. We operate at the data frame level, so it's really easy for a new contributor to just take their own framework for ML or even library, if it's something more specific, figure out the mapping, and then if you install those dependencies, you can have it running essentially as an AI table abstraction where you've got your ML models and they behave as though it were data. Of course, with additional latencies when the model's more expensive to run, but that's sort of the abstraction here. Now, the main components that we're using for LangChain as of now, again, understanding this is a huge set of like potential, let's say, LangChain stacks, right? What we're doing as of today is essentially using a React-based agent. Now, React is a very cool paper from people at Google and Princeton, and essentially they figured out a way to perhaps constrain the action space of a large language model and structure it in a way that it acts, it observes, and it thinks. And doing this, you gain access to tools that are an interface to the external world. And it's sort of a perfect blend of reasoning plus action. And this is really powerful. Maybe I'm mistaken, but this is one of the first moments where LangChain was like viral, where people had this realization that, oh, actually, large language models, if prompted this particular way, they're very powerful. Like we can do a lot of useful stuff with the right tools. So in the example down here, you can see, there's a tool called Think, and then it actually reasons about a whole series of steps where the mission is to like essentially put some object within a big room, right? And it's going step by step, which is another paper that's used as a reference here. And it reasons, it's a pretty long chain. So what we're doing in the MindsDB integration with LangChain, we're using a React-based agent, which is quite a complex beast, as you can see from the example. And we're augmenting it with a conversational summary memory in case that let's say the tokens in the thought process overflow what the receptive field of that model is. And we're providing some external tools. By external, I mean outside of MindsDB. And then some internal tools, which is like in my opinion, the novel bit of the integration. So for external, we have Google search, Wikipedia, some other useful web pages. Python REPL, which is I'm pretty sure we'll discuss it at some point today, but it's a double-edged sword. You need to be very careful with that. And then the cool thing is we actually have given access to the MindsDB executor. So what I mean by this is we have a stack of like SQL, like a SQL pipeline. So we parse things, we plan queries internally depending on the data source that you're using, so that it's possible perhaps to, I don't know, like if you have 3 different data sources and you want to have a huge, like a single view from which you will train your machine learning models in MindsDB, we have a way to deal with that, right? And finally, the executor is what actually executes those steps in the plan, marrying all the data sources and the machine learning models. So LangChain has access to this, and that's pretty exciting because it's essentially a way to automate a lot of the reasoning that people may do in a first pass when using MindsDB, right? So you can fetch metadata, you can read tables, you can write to tables, depending on the permissions you grant the agent. And yeah, it's literally as if you were automating, let's say, a MindsDB developer that would connect some data source with some machine learning engine, right? So that's very interesting. Some examples that are from MindsDB itself rather than LangChain on its own. In this case, you're just like fetching the wiki quotes page on Albert Einstein, getting some quotes with a reference back to the user. You can see here in the first block here, we have the SQL editor from MindsDB. We're just calling a LangChain model. We'll see in a bit how to create one. But essentially, you're giving an input, like a synthetic input, a single row, so to speak, in the tabular world, and just giving a budget of 5 iterations. This, of course, has a direct impact on the cost of the call to the large language model. But it essentially, so the takeaway here is that it uses Wikipedia, it uses Python, and then it gets back the completion to the user. It can get a bit more complex. So if you ask something that actually involves maths, it would use Python for multiplying the numbers. Then actually, as we know, large language models, depending on which one you use, can be great at code completion as well. So it actually it writes an isPrime function. It evaluates the function with the right number, right? And then it says, well, it's not prime, which is the correct answer, by the way. So that leads me to a very short demo. I think we're right on time. For a Dungeons & Dragons Dungeon Master Assistant. Now, we have a few geeks of Dungeons & Dragons in the team. We know it's a time sink to prepare a campaign, especially if you have to cross-reference different sources of truth in terms of what monsters to use in your campaign, what places you want to visit, etc. So the demo here is just It's not a chatbot per se, it's more an assistant that goes, looks at your data, living in a database that's connected to MindsDB, and then uses LangChain to operate over it, as Harrison showed, like a sort of a SQL database agent, only that it uses the MindsDB executor, right? So that's like the plot twist here. Let's see if we can get it to work. Right, so I have a live connection to MindsDB here, and the demo is around here somewhere. Here we go. So I won't go into the details of connecting the data source. It's, as a user, you would just connect your database. No surprises there. And we have a table that has the summary of, so it's from Kaggle in this case, but it's essentially each monster name has some set of attributes that is useful for a dungeon master. Stuff like how fast it moves, intelligence, wisdom, health points, and so on, and challenge rating, also a very important one. And then in terms of creating the model, which is what we missed on the slides, you're essentially creating a MindsDB model, as any other, predicting for a column that doesn't exist in the data set. You're not, so something we're missing here is the from clause that you would typically use when you're training from a data set, let's say a regression problem or a classification problem. In this case, we're just fabricating or synthesizing the answer. So we just say, we'll predict something, and it's going to be called recommendation. And the using clause sort of it will parameterize the model. In this case, using the LangChain engine. So it could be, you have a lot of options here, but of course, we want to use LangChain using GPT-4. And we will have a simple prompt template for now, just for the sake of example, because we can override this at prediction time, which helps with the agility of the developer when figuring out maybe the prompt is not optimal. Well, you can just go and correct that at prediction time. And in terms of tools, we're actually just passing an empty list here. We don't want to give external access to this particular agent. So we won't give anything apart from the MindsDB read access to the executor. And of course, verbose, because we want to see what's happening under the hood here. So while the query runs, because again, reasoning can be expensive in terms of runtime and also dollars, we'll take a look at the query. So we're just passing an input here, which is what the dungeon master wants to check out. And again, you can do bulk prediction. So if you instead used a join clause here and passed a table with a bunch of different requests, this is going to do a prediction with a batch instead of just a single one. Where is perfect for just poking around and seeing how the model behaves. So we're creating a recommender in the previous step, and we're using it here with a bigger budget of iterations, 20 in this case. And here we're overriding the prompt template to be something that, of course, there's a bit of a prompt gradient descent here, but we are at let's say, an optimal prompt through trial and error, where this thing actually works very well. So we're doing a few things on the top half of this prompt where we set the stage. It's a Dungeons & Dragons campaign assistant. You want to help recommend the best monsters in the campaign, given what the DM is asking for. And then a few let's say, best practices when operating with the MindsDB stack. So always remember to check the metadata before poking around a table so that you know what columns there are, what data types are involved. Check the valid values with a distinct query. Limit your clauses just in case to avoid overflowing the token buffer. And then if you get syntax errors because you're using something that's way too sophisticated, or perhaps it comes from some particular database flavor, then please revert to something more simple, because at the moment anyway, MindsDB just operates on a subset of SQL, right? And finally, we inject DM's request here. So this thing executed. I'll quickly scroll over to the final answer and just show you that for the question of the DM, which was, I have a tropical jungle campaign with a group of level 7 and level 8 adventurers. What are some moderately challenging monsters? And it provides a few recommendations. Some of these may be what you would expect in a jungle, I guess, so ape, elephant, perhaps. And they have levels of challenge, like challenge ratings that, in my opinion, are decent challenges. So it's like a fine answer, right? And in terms of reasoning, if we go back to the chain here that gets executed, you can see that maybe as opposed to Harrison's examples, we're using the MindsDB tools. So like the metadata to get the information about the MariaDB monsters table first, which is provided by the executor of MindsDB. Now that it knows the columns, it knows what to query for with a distinct query. And then again, it sort of fails to provide the right format in the React framing. So it's missing, like, it has to say action before actually doing the action, right? So it tries again with that fix in place, which is done automatically by LangChain, which is awesome. And then just figuring out what monster types there are out there, picking a few from this like summarized answer to something that would be appropriate for a jungle setting, and then just essentially like arbitrarily setting a range of challenge ratings that would be appropriate for what the DM wants. Finally, getting a few rows out of that, like out of the SQL query that it compiles, and then just formatting the final answer that appears in the SQL editor. So this is pretty interesting. Like you can take this thing, you can run it as an automated job. MindsDB has the concept of jobs that run at some frequency. You can also hook it up with APIs. I think there's a customer later on that's showing how to do that. So you can also like deploy this in chat-based sort of contexts. And that opens up a lot of doors that we're just recently like getting to explore in more depth. I'm personally very excited to figure out the role of LangChain as a sort of an AutoML orchestrator when you have access to different frameworks, different data sources. How does that work really? But yeah, that's the demo. I think we're right on time for a set of Q&A if anyone has any questions. But yeah, thank you for the patience here. I guess one last thing would be in terms of future work. I forgot to mention this. We know from Harrison's talk, there's a lot of ground covered by LangChain. Our own implementation right now is very, I don't want to say basic, but it went directly towards the place where we thought there would be most impact. Having said that, we can improve the coverage of supported LLMs, types of agents, types of memories, right? Even some components we don't use at all. So like text splitters, summarizers are things we're not currently using. Agent robustness is a huge one. Prompt templating is pretty much an art right now, and we want to sort of elegantly deploy best practices for interacting with MindsDB through LangChain. And yeah, finally, there should be an easy way for us to provide custom logic as new tools, which is really powerful as well in terms of just opening up the doors to these large language models that we know are so awesome. So yeah, thank you very much. I'm opening it up now for Q&A. So. So we can make it available easily. There's a few fixes that I may have pushed yesterday, but they will make its way into the repo really soon. And at that point, you can fully replicate this with the 3 commands that I posted. So I'll do that after the talk so that you can poke around.
From a live stream, so this is from Harrison. How can I get started with LangChain? What are the key features of LangChain? What are the best practices for developing applications with LangChain?
Oh, there's a lot there.
Go wild.
Okay, how to get started with LangChain. So we have Python and TypeScript packages. Both of them have basically to get started with LangChain. I would probably suggest you figure out an application that's interesting to you. The beauty of the large language models is they're so good at so many different things. There's got to be something that's pretty interesting to you. We have a lot of, and then in the LangChain documentation, we have a use cases section. And so I would find kind of like the use case that's most similar to that thing. A lot of the use cases you get started with in like 5 lines of code or something like that, and you have like a chatbot up and running or something like that. So I would get started there, and then from there I would dive into all the stuff that Patricio talked about. I actually think what you added was like very advanced in terms of like it was a completely new prompt template. There was a lot of parameters that you were passing, and so I think like I would definitely start high level at a use case. There's a lot of ways to get started in like 5 lines of code, and then there's lots of rabbit holes that you can go down. I completely forget the next 2 questions.
So what are the features of LangChain? What are the best practices for developing applications of LangChain? What are the best practices for developing applications
Okay, cool. Yeah, the key features of LangChain, I think a lot of them were highlighted in kind of like the modules and components part. So part of what LangChain, right now it's this exciting new era in building with LLMs where, we've been building with them. Most people have been building with them for 8 months, maybe a year, and so no one like really knows 100% what the best practices are, but we've tried to crystallize what we think the most like common and good abstractions are into these like components. And so those are kind of like the key pieces, and the key piece, like in going, in order of priority, I'd say like, the language model is kind of like the most key piece. And so we've got kind of like a component there really focused on that. And then there's kind of like language model input and output. So like the prompt as the input, the output parser as the output. And then on the other end, there's a lot of things related to data, because I think a lot of the applications that we help enable are when you connect language models to data. And so there's a lot of there's a whole section on the documentation around document loaders, like preprocessing text splitters, embeddings, vector stores, retrievers, things like that. And then the third area of what I'd say there's a lot of components in LangChain are the agent and the reasoning stuff that Patricio showed off. So this idea of using a language model to recover from errors, as he showed off, and to decide what to do next. And so I think there's basically models and models input and output stuff. There's data and data and connecting that to language models. And then there's the agent stuff and all the tools that agents can use as well. So I think we have 50 different tools ranging from Power BI to Hugging Face models that you can call as tools to do image generation and stuff like that. Best practices for building with LangChain. I think, when I build with LangChain, I think what I like about LangChain is that I think it's pretty composable and modular, and so there's lots of different components, and so I think it's very natural to start high level with a chain, and then as you go deep, you're going to realize that, oh, I need to change this prompt, and so we should have, for most chains, pretty easy mechanisms for passing in custom prompts, and then if you need to actually change some of the logic inside the chain, the inner workings of the chain are just other chains for the most part that are called. And so, you can kind of copy that code, bring it out, and then there's still these building blocks of LangChain, but you're now just creating your own custom chain. And so I think, in terms of best practices, I would say start high level, don't be afraid to dive deep, and then a lot of it, I hope, is enabled at composability, so hopefully that should be pretty easy.
I'm going to go back to the audience. We have a queue of questions on live stream, but anybody here have questions? Yeah, go ahead.
Hi, how would you connect your own models with LangChain if they're not open source or on Hugging Face or other places?
Yeah, so this is a great question, which is basically how to connect. And I'm going to extend this even more to how to connect maybe your home vector store or your home retriever or anything like that. So a lot of basically the LangChain abstraction is just an interface that needs to be implemented. And so you can kind of subclass a class and then implement a function. So for language models in particular, you can subclass kind of the base LLM class and then implement a method, which I think there's a simple one that takes in a string and returns a string. Mm-hmm. And you basically just put whatever references your own models in there. And then you can pass that around and use that to configure all the other chains like you would a normal model that exists.
Okay, I'll try it out. Thank you.
Okay, going quickly back to the live stream. How is MindsDB helping ship LangChain projects into production?
Sure, yeah. So I think the main benefit potentially is the fact that you don't have to hop around. There's a single, let's say, place where your data lives already. It doesn't necessarily make a lot of sense to set up a separate silo for this. Instead, you can sort of go through MindsDB, connect the data source immediately. Even if it's actually multiple data sources, you can also do that. And then just get something running up very fast. And when it's time to production, literally the model's already a SQL table, so it's it should be hopefully zero friction. So yeah, I think that's probably the best, the biggest benefit. Not sure if, yeah, I think that answers the question. It's the main benefit.
I think that's good. We have a bunch of the same question, which is, will the repo get posted online? Is the repo available?
It will be available. Yeah, we'll make a separate repo for you guys to like clone and just play around with MindsDB on the side. Yeah. Yeah. So no worries there. We'll get to that.
Any more questions?
So as these language models and libraries like LangChain are making it super easy to connect data sources and query it, what do you think will be the key differentiator between company A and company B doing the same thing? Is it just the quality of the prompts? Is it fine tuning? Where do you think like the special sauce or like the moat of companies trying to build apps will be?
Yeah, I think that's a really good question. I think, well, one, I don't think anyone really knows for sure. Like, I think that's part of the excitement around, like, yeah, it's an amazing time to just be building things. My best guess to that answer is I think part of it definitely comes down to the data. So there's definitely the data that like you as a company have and can expose. And I think these types of interfaces make it really easy to expose that data to other folks without giving away the underlying like data itself. I think there's also a separate thing, which is gathering kind of like, or seeing how users interact with that data and using that to improve your own prompts, models, or even data sources. So what I mean by that is, I think the obvious one is as you see people asking questions about your data or interacting with your data, let's say, and if you start to gather feedback on that, you can start to see, like, you can start to like A/B test different prompts. You can maybe start to use some of that data to fine tune models. I think to be clear, I think those are still like things to aspire to. I don't think most people are doing that, again, because it's so early and so exploratory in a lot of things. The other like interesting thing that I'll just say is like, as you're doing this, and this is something that I want to do more internally, we have like chatbots for the LangChain documentation, or we work with companies that have chatbots. Those are full of insights, right? Like, what are people asking questions about? Oh, that probably means our documentation isn't very good there, or we should beef that up or something like that. And so I think that's another way to just like, yeah, get this kind of like data flywheel turning. And a lot of it comes back to like evaluating, yeah, like how good the model's doing. The other thing I'll say as well is just like, I think another way to differentiate is like the depth of integration that you do. So I think like at the end of the day, if you're a single call to an LLM, there's not much defensibility there. If at the end of the day, if you're doing like retrieval augmented generation from like a vector, from like a single vector store, and you're just doing like a single chain, honestly, I don't know how much differentiation there is as well. But if you look at like Copilot, they're like the way that they construct the prompt is incredibly complex. Like they pull it from like 4 or 5 different sources of like information, and there's this art now of like prompt engineering, but I think like a better word for it that I like is like prompt construction. Like it comes down to how you construct the prompt, and Copilot does this extremely well and extremely cleverly, and it's not like it's not a single call to a language model. It's a complex system where they're constructing this prompt and then passing it in. And so I think there will be defensibility in adding more of these complex systems and integrating them more tightly with a bunch of different sources and getting that kind of going.
May I just add a couple of things here? I think one is just how well the model is aligned. So when you see like agent behavior, like the one we showed off here, a lot of times the agent will, let's say, fall out of bounds, and then it will be on uncharted territory where ideally you want it to behave a specific way. So there it becomes really important how the LLM provider actually trained even the policy, right? Usually with reinforcement learning on how the model behaves there. And that's a huge potential differentiating factor. Another one is that you're seeing companies start doing different types of bets. So for example, Anthropic, I think, is now trying out huge contexts where you have like 100,000 tokens or something, where that becomes super, super powerful and again, this is a research question that's open at the moment, but it's not entirely clear whether it's just better to do fine-tuning or to just do in-context learning, right? So if you have a huge context, you can fit a lot of examples. So I want to say it's a really just an open field right now. We need to perhaps wait a bit more until figuring out, like, apart from everything that Harrison said, like this, what are the key factors? Yeah.
Well, if I can add to that, you reminded me of another thing as well, which is to the point around like the agent, and it be like agents are still like, you saw it mess up twice in that one demo, right? Like they're still not they're still not kind of like, they're still not off the shelf fully reliable. And so like to be specific, what I mean by that demo is using like a zero-shot prompt. So we kind of just like tell it what to do. The main way that I've seen kind of like getting agents to be reliable is by providing like few-shot examples. And the main way that you do this is kind of like collecting these examples. You don't start with them, right? Like I think that's the beauty of these generative AI applications is you don't start with data now. You start with an idea. It's really easy to use these language models. You can do it zero-shot. You can tell it what to do. But then I think the number one way to improve these types of applications is start collecting these few-shot examples and using them in your prompts to help guide it into what to do. And so I think like, you know, I think getting that like, and this gets back again to like the evaluation part of it, but getting that evaluation data flywheel turning is incredibly important for enabling these more complex applications.
Okay, I think we got time for one more. There you go.
Thanks so much. Just a quick question. So do you already support, or do you plan to support in MindsDB also, you know, storing the embeddings directly as a column? Or do you have an integration with pgvector to enable this rag that Harrison was talking about?
Yeah, that's a great question. So we're actually finishing support. I think likely today you'll see a demo about that, like really close to the embedding concept. Right now it's per integration, but we want to unify it into like a more standard interface so that people can do let's say the vector DB operations like from the first step without having to delve into the details of a particular ML engine, right? So because we're seeing patterns, it's fairly established how they work now. We want to try to make that simple so that you can get going with vector DBs even faster. So the answer is yes, and there's like multiple fronts of work that we're trying to explore actively. Yeah.
Cool. Excited about that.
Yeah, for sure.
The cool thing about the data we have in our database is that you don't only have text data, you also have you know, numerical data, categorical data, and MindsDB, to solve all the problems that it needs to solve, it needs to create an embedding for each of the columns that you have, and therefore it is really good at building a full vector representation of a row. So you can solve, yeah, like semantic search that you will do traditionally for just when your table only contains text, but you can do search for recommendation engines where you're finding the nearest neighbors given the full vector store and the full vector representation of the row. So I think that's when it starts to become really interesting, where you can combine text plus other type of column information that is not just text, and use the vector store databases to solve problems that before were really hard to solve, such as recommendation engines, etc. Okay, thank you very much, guys. That was great.